Q6693. Which type of flap is characterized by large increases in lift coefficient with minimum changes in drag? A. Split. B. Fowler. C. Slotted. The correct answer is B. Fowler flaps are characterized by large increases in lift coefficient with minimum changes in drag compared to the other types of flaps. Fowler flaps have a unique design where they slide rearward and downward along tracks when deployed. This movement not only increases the wing's surface area, but also changes the wing's camber. By increasing the wing area and camber, Fowler flaps are able to generate significant amounts of additional lift. One of the advantages of Fowler flaps is that they achieve this increased lift with minimal changes in drag. The design of Fowler flaps allows for a smooth and extended flap surface, which helps maintain laminar airflow and reduce drag. This results in a favorable lift-to-drag ratio, allowing for a significant increase in lift coefficient while minimizing the increase in drag. In contrast, split flaps and slotted flaps, while also capable of increasing lift, tend to have larger changes in drag compared to Fowler flaps. Split flaps, which consist of a hinged plate that deflects downward from the lower surface of the wing, can generate additional lift, but often at the cost of increased drag. Slotted flaps, with the presence of a slot between the flap and wing, can delay the stall and increase lift, but they may also introduce some additional drag. Therefore, the correct answer is Fowler. Fowler flaps are characterized by large increases in lift coefficient with minimum changes in drag. 6539. An airplane leaving ground effect will A. Experience a decrease in thrust required. B. Experience a decrease in stability and a nose-up change in moments. C. Require a lower angle of attack to attain the same lift coefficient. The correct answer is B. When an airplane leaves ground effect, it will experience a decrease in stability and a nose-up change in moments. Here's the detailed reasoning for this. Ground effect refers to the phenomenon where an airplane experiences increased lift and reduced drag when flying close to the ground. This is primarily caused by the reduction in downwash and the compression of airflow between the wings and the ground surface. Ground effect is most significant when the airplane is within one wingspan's distance from the ground. When an airplane is in ground effect, the compressed airflow and reduced downwash contribute to increased lift, which helps stabilize the airplane and maintain a nose-down pitching moment. This means that the airplane's stability is enhanced, and there is a natural tendency for the nose to stay down. However, when the airplane leaves ground effect and flies at higher altitudes, the compressed airflow and reduced downwash diminish. As a result, the stabilizing effect of ground effect decreases, leading to a decrease in stability. The airplane becomes more susceptible to pitch changes, and there is a tendency for the nose to pitch up. This nose-up change in moments requires the pilot to make control inputs to counteract it and maintain stable flight. The pilot may need to apply additional downward elevator control or adjust the trim settings to achieve the desired pitch attitude. In summary, when an airplane leaves ground effect, it experiences a decrease in stability and a nose-up change in moments. This is due to the reduced influence of ground effect on lift and airflow dynamics. 6540. An airplane is usually affected by ground effect at what height above the surface? A. 3 to 4 times the airplane's wingspan. B. Twice the airplane's wingspan above the surface. C. Less than half the airplane's wingspan above the surface. The correct answer is C. Ground effect is typically experienced at a height less than half the airplane's wingspan above the surface. Flying at this height allows the airflow beneath the wings to be compressed, resulting in increased lift and reduced induced drag. This phenomenon improves the airplane's performance and requires a lower angle of attack to maintain the same lift coefficient. By flying closer to the ground, the airplane benefits from the cushioning effect of the airflow being compressed between the wings and the surface. This leads to improved lift characteristics and reduced drag, making it easier to maintain lift at a lower angle of attack compared to flying higher above the ground. 6537. If the same angle of attack is maintained in ground effect as when out of ground effect, lift will A. Increase, and induced drag will decrease. B. Decrease, and parasite drag will increase. C. Decrease, and parasite drag will decrease. The correct answer is A. When the same angle of attack is maintained in ground effect as when out of ground effect, lift will increase and induced drag will decrease. Ground effect refers to the phenomenon where an airplane experiences changes in lift and drag when flying close to the ground. When an airplane is in ground effect, the airflow beneath the wings is compressed, resulting in increased pressure and lift. This increased lift allows the airplane to maintain a higher lift coefficient at the same angle of attack compared to flying out of ground effect. The increased lift in ground effect is accompanied by a reduction in induced drag. Induced drag is the drag generated as a result of the production of lift. In ground effect, the compressed airflow beneath the wings reduces the size and strength of the wingtip vortices, which are a major source of induced drag. Therefore, the reduction in induced drag contributes to an overall decrease in drag. Option A correctly states that when the same angle of attack is maintained in ground effect, lift will increase and induced drag will decrease. The increase in lift and decrease in induced drag make the airplane more efficient and require less thrust to maintain level flight. 6538. It is possible to fly an aircraft just clear of the ground at a slightly slower airspeed than that required to sustain level flight at higher altitudes. This is the result of A. Interference of the ground surface with the airflow patterns about the aircraft in flight. B. A cushioning effect of the air as it is trapped between the ground and the descending aircraft. C. Ground interference with the static pressure system, which produces false indications on the airspeed indicator. The correct answer is A. Flying an aircraft just clear of the ground at a slightly slower airspeed than that required to sustain level flight at higher altitudes is possible due to the interference of the ground surface with the airflow patterns about the aircraft in flight. When an aircraft is flying close to the ground, the presence of the ground surface affects the airflow around the wings and fuselage. This interference alters the airflow patterns and creates specific aerodynamic effects known as ground effect. The ground surface acts as a boundary that limits the downward deflection of the airflow from the wings. This boundary effect causes the airflow to compress beneath the wings, leading to an increase in pressure and lift. The compressed airflow generates an upward force that helps support the weight of the aircraft. Due to this interference of the ground surface, the aircraft experiences reduced induced drag and increased lift. As a result, it can maintain flight at a slightly slower airspeed compared to flying at higher altitudes where ground effect is not present. This phenomenon allows the aircraft to fly just clear of the ground with less power and at a lower airspeed. It is important to note that ground effect is most significant when the aircraft is within one wingspan or less above the ground. As the aircraft gains altitude and moves further away from the ground, the influence of ground effect diminishes. Therefore, the correct answer is that flying an aircraft just clear of the ground at a slightly slower airspeed is the result of the interference of the ground surface with the airflow patterns about the aircraft in flight.